So we left off the last thermodynamics tutorial. Do you know the 4 laws of thermodynamics by heart? Do you know what heat is? Do you know what entropy is? Do you know what enthalpy is?
Yes, I do. But I won't say it's by heart. Because, yeah.
Okay.
Are we meant to like remember by heart or?
Yes. Yes.
Okay, cool.
You need to remember all these fundamentals by heart because they're going to help you. So for example, I'll just give you a very simple example. When a question tells you that something is not spontaneous and it is exothermic reaction and it's not spontaneous, immediately you need to know by heart that the reason for that to be true is that entropy has to be negative. Do you understand that?
Yep, I do.
Okay. And that
I can figure out from the formula that we have.
okay.
Delta G equals to delta L times P minus T times delta S.
Yes, and the problem about in the exam is that you have 1.5 minutes, so you won't have too much time. You have 1.5 minutes per question, so you won't have too much time to think. The more things you know by heart, the faster you can finish the questions. The questions that you can memorize by heart and like intuitively know the answer, when you can reduce those questions down to a short amount of time, it gives you more time for the comprehension questions and the graph reading questions, because those might take more than 1.5 minutes per question, and the more time you have, the better.
Okay.
So I mean, thermodynamics is one of those things that is just really, like, at the beginning it's hard to understand, but once you develop a mastery of it, it's one of the easier questions to answer.
Okay.
Okay, so I think one of the more complicated things about the last lesson was Gibbs Free Energy, and if you notice over here, I'm gonna just draw the box right now. Can you see how similar the formulas are? Can you draw the link between the standard Gibbs Free Energy equation and the Gibbs Free Energy of a reaction that is not in equilibrium, as well as the Nernst equation? Can you see a link? What's your thoughts on it? In future, if you're going through some material and you're having a stumbling block, there's you can always ask me. Just send me a Facebook message, or you can go on Reddit. Reddit's pretty helpful. One thing I actually told Joseph before was there's a Reddit subreddit called ChemHelp, and it's basically a Reddit where people ask questions about chemistry. And if you ask questions on chemistry there, I'm sure some helpful soul is going to help you answer it. In fact, I was using ChemHelp just yesterday because I was trying to answer people's questions. One of the good things about ChemHelp is that if you can answer the questions that are posted there, it actually shows that you have developed a level of mastery on certain areas of chemistry. Okay, so I'm going to be going through a Gibbs Free Energy that is not in equilibrium. So I'm going to highlight the main one here. This is your standard Gibbs Free Energy. Do you understand the meaning of what that is?
Is that at the standard condition, room temperature, or?
You're right. So a standard condition is room temperature, usually 20 degrees Celsius, and it's at atmospheric pressure. Now, if I have an equation, if I have a chemical equation, let's say A plus B equals to C, and I'm given a table, I'm told the Gibbs free energy of this equation is negative 10 kilojoules. What does that mean?
So the equation is spontaneous at standard condition.
Yep. So what that means is that this chemical reaction wants to proceed because the Gibbs free energy at standard conditions is negative. Now, when will the Gibbs free energy of this equation here, when will Gibbs free energy equal to 0? When Gibbs free energy is 0, we just substitute in the values to determine where the equilibrium is of this equation. So if Gibbs free energy equals to 0, that means the reaction is not occurring anymore. It's not favorable either way. And we know that the standard Gibbs free energy of this equation is negative 10. We substitute in two things. R, it's a constant. Times T, this will be room temperature, so it's 20 degrees Celsius plus 273. That's 293. Times the ln of the products over the concentration of the products over the concentration of the reactants. So this should be 8 point something. And then we'll get a number. And I'll just bring up the calculator. We get that amount. We need to divide the whole thing by 2,344. I'm just going to try and do a shortcut. Yeah, so to get rid of ln, we need to power it by E, yeah? Okay, yeah, there we go. So that's the importance of that equation. I mean, it's a little bit of, it's just dimensional analysis, and it's a little bit of math.
What is the R meant to be a constant?
Yeah, R is a, yeah, it's called the gas constant, and it's 8.3145. It's also called the molar, universal, or ideal gas constant.
So with this equation, we're trying to figure out if what Gibbs free energy is the equation in balance with.
Now this is more of, it's more about, the reason why I went through this was to develop your intuition of what Gibbs free energy is. We went through this equation here, and it had a Gibbs free energy of negative 10 kilojoules. So what does that mean?
Yeah. It's spontaneous.
That's right. It's and then the key thing is the standard sign, which means at 20 degrees Celsius at 1 atmosphere, this reaction will happen spontaneously. But then,
yeah,
as the reaction happens, this number here, negative 10, it's actually, if you plot it on a chart, it's going to keep going up. So I'm going to draw a chart. Yeah, and then it starts off at negative 10, a ratio. And the ratio, let's call this ln C over that. That's the x-axis, and the y-axis is that. Yeah. So when you only have A plus B and very little C,
yeah,
you're gonna have something there, and that's negative 10. And as the reaction proceeds, it's gonna go all the way up like that. And at a certain point where the ratio, the Gibbs free energy equals to 0, which means it's not going to happen anymore. We want to put ln on the x-axis. So Gibbs free energy y equals to 2344. -10. That's like a constant. So this looks similar to y equals to a x -10.
Yeah.
Yeah, so then the graph will be a straight line, yeah?
Yeah.
Okay, so what I was trying to do was to build the intuition. At standard temperature, if you only have A plus B and very, very, very little C, I can't say 0 C because that might screw up the equation, I think. It'll become a undefined equation. So A plus B, if you have only A plus B and very little C, your Gibbs free energy is -10. And then the reaction will keep proceeding until the Gibbs free energy goes from -10 to 0. Where there's no more potential energy for the reaction to occur.